Topic 4 deals with water and aquatic food production systems. Today we will look at water use and how humans have impacted our water cycle. So if we look at why we use water, it keeps us alive. It's required for all living organisms. It moderates climate, sculpts the land, helps to remove and dilute wastes and pollutants through our wetlands, and it's continually moving through the hydrologic cycle or water cycle. The water budget deals with the amount of water we have available to use on Earth. So if you look at this diagram, inputs into the water budget would be precipitation, runoff, groundwater inflow, surface water inflow, and water diversions, which is like taking a river and diverting it or building a dam on it to provide a water source. Outputs would be any way that we lose water as an available resource. So evaporation, transpiration, surface water and groundwater outflow, irrigation, using it for industry or residential uses, and water diversions. So not all water on Earth is in a usable form, and as long as we are using it sustainably, it's considered renewable. So water in the atmosphere in our rivers, because it moves through the water cycle very quickly, usually less than a month, can be considered a renewable resource. However, we do have some sources of water that can be considered non-renewable. Water molecules that are in the ocean, especially deep oceans, and then ice caps, are locked in for extremely long periods of time. Groundwater is one of those that can go either way. If we're using it sustainably, it can be renewable, but many of our aquifers are being depleted because we are using it faster than it can be recharged, so our groundwater sources are quickly becoming non-renewable. If we look at how water is distributed on Earth, now this is freshwater and saltwater. So the first column here is the total global water. 96.5% is in the oceans. We also have saline water in the ground in the lakes. That just means it has a higher percentage of dissolved minerals. Then of the water on the earth, only 2.5% is fresh water. So the second bar here represents all fresh water. Now, much of that is in glaciers and ice caps, so it's unusable. 30% is groundwater, and then just over 1% is surface water and other fresh water. So our third bar here is the surface water. And if you see there, of a surface water, 73% is ice and snow. 20% is lakes. Some of that water is atmospheric water, biological water, so what's found in living organisms, rivers, swamps, and even water in the soil. We consider that the topsoil. Water that's in deeper soil would be groundwater. Because such a small percentage of our water is fresh water, we don't have enough fresh water to meet our needs. Only about 41% of the world's population, which is over 7 billion people, live in river basins that don't have enough fresh water. We're seeing rivers running dry because of overuse. Lakes are shrinking. Oceans are shrinking due to evaporation. Not oceans, seas like the Aral Sea. So those are our bodies of water that are landlocked. And then we also see falling water tables from overpumped aquifers, and we'll talk a little bit about groundwater later and what that means. In these two images, you can see this is the Colorado River and what used to be the Colorado River Delta, where all this was submerged in water. Now you can see how the river is running dry. And this is Lake Mead, which is behind the Hoover Dam, which is one of the dams on the Colorado River. Because of high evaporation rates and overuse in our desert areas, we're seeing our lake levels fall as well. Some of our human impacts, one of the biggest is overuse. In the U.S., our biggest use of freshwater is for agriculture and irrigation. What we use in our homes is actually a very small amount of the water that is used. But irrigation and industry are going to use a larger proportion. So what we're seeing, some of our rivers and seas in North America, the Colorado and Rio Grande, we're seeing some pretty negative consequences. The rivers are running dry. In Central Asia, there are two rivers that once fed the Aral Sea, and we'll take a look at the Aral Sea in class and what's happening there. In China, we're seeing issues with the Yellow River, the Teesta River in India and Bangladesh, and the Murray River in Australia. Water stress is the ratio of total withdrawal to total renewable supply in a given area. A higher percentage means that we have more people competing for a smaller supply of water. So looking at this map, these are the river basins across the world that have the most people. The areas in red, you can see that water stress is extremely high. That means we have a lot of people depending on a small amount of water. And then the orange is medium to high. So looking at the U.S., our largest river basin right here, that's the Mississippi River Basin, where a lot of our agricultural areas are. So we're using a lot of that water for irrigation. Right here, this is the Colorado River Basin, and there are 7 states that depend on water from the Colorado River to support the population. So that is a very stressed area. And then other parts of the world, over here in India, and the southern parts of Asia, we're seeing some of the same problems. We have a large number of people that are depending on a small amount of water. Desertification is becoming a problem, especially in the areas surrounding our deserts, which were previously grasslands. The area becomes increasingly arid or dry, meaning it's losing its bodies of water, any vegetation and wildlife that help support the soil. And this is caused by a couple of things. It can be climate change, which leads to more evaporation, but a lot of human activities, mainly overgrazing and poor farming practices, which leave the soil exposed. And you can see here a before and after of an area that's already arid that has become even more dry. So this map shows in red are the areas that are already deserts. They're desert biomes. And then the surrounding areas in yellow are those that are currently vulnerable to desertification. Those in green, like on the east coast of the U.S., we're a temperate deciduous forest. We get plenty of rainfall, so we are not vulnerable to desertification. But in the western part of the U.S., where there's not as much rainfall, and we have some of our grasslands, our chaparral, our desert biomes, we have much more vulnerability. All right, so I mentioned groundwater as being a source of water. Unfortunately, because we are starting to depend more and more on groundwater, 20% of our aquifers have been overpumped. So you can see the color code there. The blue are some major groundwater basins. The green are this complex hydrogeological structure, so that means it's a little bit harder to withdraw groundwater. And the tan areas are local or shallow aquifers, meaning you're not going to have a very large supply. So the blue areas are areas where we have plenty of water. Now on this next map, this shows the recharge rate, or how fast groundwater is being recharged through infiltration and percolation. So areas that are in blue, the rates are pretty high for recharge, meaning it happens pretty quickly. But in yellow and orange, it's very slow. So going back to this map, it doesn't always match up that our major groundwater basins recharge very quickly, especially if you look in the western part of the U.S. And once again, that goes back to not having much rainfall. One of our largest aquifers is called the Ogallala, and it's this blue one right here. And that provides a lot of the irrigation water for the Midwest. But notice in this map, it's medium to low in terms of recharge rate. So we are withdrawing water faster than it's recharging. All right, so what groundwater looks like. As water filtrates through the ground and percolates, it becomes saturated. This is called the zone of saturation. It fills in the pore spaces in the soil and the rock. The top layer of that zone of saturation is called the water table. The water table can rise or fall depending on amount of rainfall and amount of water that we're withdrawing. But when we withdraw water, what we do is we dig a well down into that zone of saturation and we pump it out. Any area of soil or rock that can transfer water is known as an aquifer. So we dig our wells into aquifers. Where the water table comes into contact with Earth's surface, that is a spring. And groundwater can also flow into streams, which feed into rivers and lakes and affect our surface water as well. So when we withdraw groundwater from aquifers, advantages are that it provides drinking water and irrigation. It's available year-round. We're not losing water due to evaporation like we do our reservoirs in the summertime. And a lot of times it's cheaper to extract than from the reservoirs. We don't have to spend millions of dollars on building dams and water treatment. It's naturally filtrated as it moves through the soil. Disadvantages is that if it's overused, the water table can drop. If an aquifer becomes polluted, it can take decades or even centuries for that pollution to disperse. Near coastal areas, if groundwater is overused, then you get saltwater intrusion, then renders your aquifers unusable. Human impacts on infiltration, just ignore my lovely spelling area there. Anytime that we cover the surface and we're covering up that natural ground cover, we are preventing water from seeping into the ground. So natural ground cover, notice that we have both shallow and deep infiltration, and we have more vegetation, so there's evapotranspiration. When we have 10 to 20% impervious, which means that water cannot flow through, already our evapotranspiration is dropping because we have less vegetation. We have less shallow infiltration and less deep infiltration. When we have 35 to 50% impervious surface, like we do in industrial and urban areas, we have even less infiltration into the ground. Look at this deep infiltration. 15% compared to 25%. So we're not going to have the recharge rates of our aquifers than we would in our natural areas. The other thing I want you to notice, with natural ground cover, we only have 10% runoff, whereas with 30 to 50% impervious surface, we have 30% runoff. This is why we tend to have flash floods in urban areas, because there's nowhere for that water to go. It's not going to infiltrate into the ground. Other human impacts on the water cycle: pollution. Fertilizers can lead to eutrophication. Heavy metals can pollute some of our surface waters. And then if sewage is dumped into our bodies of water, that can affect dissolved oxygen levels. It can spread disease and infect organisms. When we change the flow of rivers by building concrete channels, straightening rivers, building dams, or diverting rivers, we are affecting the water cycle. Using dams and reservoirs, advantages: it provides water for irrigation, for drinking water. Reservoirs are useful for recreation and fishing. It can provide electricity, and it can reduce downstream flooding because we control the amount of water that goes through the dam. However, to build the dam, the reservoir is going to flood forests or croplands and displace people that were living in those areas. We're now going to lose a lot of that water to evaporation. A lot of the sediments that used to move downstream are going to be blocked behind the dam, so that nutrient-rich silt is not going to reach those croplands and estuaries as they did in the past. If something happens to the dam, we can have catastrophic flooding downstream, and also it's going to disrupt migrations of fish. We also have the problem of having too much water anytime you have heavy rainfall or rapid snowmelt, and this has been affected by humans, as we saw by creating more impervious structures, by removing vegetation, destructing our wetlands. Looking at these two diagrams, the first one on the left is before deforestation, and notice that there's more evapotranspiration, so that's reducing the amount of water that's running into the river. It also reduces soil erosion. If you look at the second picture on the right, where trees have been removed, there's landslides, there's gullies that have been formed by erosion because there's no vegetation to hold the soil in place. So as the sediment falls into the river's more shallow, so it's more likely to flood its banks. We also have more rapid runoff, so we tend to see more flooding with less vegetation. Floodplains are the areas that surround the rivers that usually flood during or that are covered with water during a flood. This is the Mississippi River Valley, and you can see this is during a normal flow period. This is during a flood. It's great agricultural land because of the sediments that are deposited on the floodplain leave a lot of nutrients